Hi, hello, vanakkam, and welcome back to yet another episode on everyone's favorite Little Slaw YouTube channel. And today we are going to dive into a very critical concept for anyone who is serious about load testing and that too with Locust. So, if you've ever written a load test script, whether in JMeter, LoadRunner, or even Locust, you know the frustration when your script suddenly fails because of mishandling of dynamic data. So things like session IDs, the CSR of tokens, or unique product IDs, which changes with every user interaction or with every server interaction, right? So don't worry. Today we are going to tackle the correlation in Locust, and in fact, we have handled correlation in JMeter, LoadRunner, NeoLoad in our previous videos. So if you want to watch them, please go and watch there. For now, here in this video, we're going to correlate the dynamic values in Locust. So we'll move super fast with very minimal theory and maximum hands-on coding, and I'll show you exactly how to extract the dynamic values from a server response and reuse them in the subsequent requests. And by the end of this video, you'll be able to build robust Locust script which truly simulates the real user behavior. And let's jump straight into the code. So let me quickly explain you what is correlation and the problem. So before we code, let's quickly understand why correlation, or why should we use correlation. So correlation is again the process of extracting dynamic data from a server's response and using it in a subsequent request. It looks very simple, right? But the reality is it's very crucial. So imagine you have a very simple web page. So for our demo today, I have set up a super basic application. Let me quickly do a login. Yep, so very super simple basic Flask application which simulates a login process. So when you hit the login page, it generates a unique token that must be sent back when you actually submit your username and password. So if you don't send the correct token, your login will fail. So that is what I have coded, and that's what we're going to test today. So here is I've even in fact used a very simple basic native Navy Locust script which I'll use to try to log in. And what it does is it just visits the login page and then it tries to post the login credentials with the hard-coded static token, and it will actually fail because it's a static token, and we all we wanted is a dynamic token, right? So our job is to correlate that token, grab it dynamically from the first request response and inject into the second, and that's what we're going to do today. And as you see here, I've got a token here, and then when I refresh it, it keeps on changing, right? So if you see here, starts with EZ and then E50. So every time when I log in, or every time when I come to the landing page, I could see a different server token here, right? So I have set up the application already, and if you want, please let me know in the comment section. I'll send you the code where you can use it for your demo purpose. So I have set up this application. It's basically a Python application, and I have used this login credentials part. And let me just, I'll even show you the test user password 123. Yep, so this is how it successfully log in with the token. And here's the dashboard. As I told you, this is very basic login application, so don't worry about it. Our focus today is on the correlation part. So now our part is to go back to VS Code. So let me minimize it for a moment. And here is my VS Code, and for the main event, so we'll see how to correlate in Locust using the Python's powerful string manipulation and regular expressions. And here is my code. I'll just go paste it here and I'll explain it to you. Don't worry about that. So I have my code starting from the Locust part, and then I have the class which I have inherited here, and I'll just explain it to you. So a quick breakdown of it. So starting from import RE, which is the regular expression module, because we need to import the Python's built-in RE module, which is for regular expressions, and this is our go-to for pattern matching. So in our other applications, like we use a regex parameter and regular expressions, right? So for this, for Python, we must import this RE part. Without this RE, we won't be able to extract do the correlation part. And next is the user data. in line number 10 that you see here, where we create a simple Python dictionary called user data within our HTTP user class, right? And this dictionary will hold any dynamic values that each individual simulated user needs. And it's very crucial that this is an instance variable, that is self.userdata. It's not a class variable. So each virtual user gets its own unique data. And then the next critical part is the response of self.client of get of login, where we are gonna get the login page. So we make a initial get request to the login page, right? So once we go to this login page, right? So I used to get this login details. So that's my first transaction, and then the error handling. So what I do as the next step is I should add a response code condition. So if the condition is not equals to 200, which means, or if it is a response failure, I should immediately catch the issues, right, with the first request. So if the first request fails, there is no point trying to correlate. So in fact, for each and every step, we should actually have this the checking part, because if it doesn't pass, or if it fails, then there is no point of doing the next action, right? And then this here is the critical part. So what I do here is the match equals RE. So RE, the regular expression part, the regular expression library from Python, and I'm going to use the search. So this re dot search, please don't miss this. This re dot search is what this function scans through the response dot text. So response dot text is the total response of this previous request. So I'm scanning through the response dot text, so the HTML content that we got back. So for looking at our pattern, and then I've got the the R function, right? So this is the prefix, which means it's a raw string, right? So which is a good practice for regular expressions to avoid issues with the backslashes. So that's why I use R. And then I'm going to use the CSR of token, right? And the value equals. So this is a static left boundary. So now static left boundary, I'll just show that to you real quick, um, where we get the CSR of token. So again, it's very common. So whenever we want to extract a variable, what we do is we used to correlate it using the left boundary and right boundary. So here we do have the static left boundary, which is name equals as a CSR of token and equals value. And then we have got the dot plus quotes, which is the, sorry, dot plus quotes, dot plus question mark, which is the capturing group. So again, it's a very lazy capturing group, but still the dot matches any character, the plus matches one or more times, and then the question mark, which is the non-greedy quantifier, which is very vital because it tells the regular expression to match the shortest possible string that satisfies the pattern. Stopping at the first double quotes it encounters. So without question mark, it would greedily match everything until the very last quote on the page. So that's why we are using the question mark to keep it very short, to get the shortest possible value. And we have got the double quotes, which is our static right boundary, and then we have got a dynamic token. So in line number 31, if you see, you could see the dynamic token part. And what we do here is, and again we are matching the group of one. So if you remember, we do the same thing in JMeter as well. We do use the regular expression extractor, and then we use to match the group. So if a match is found, then match.group of one will extract the content of the first capturing group, which is the part inside the parenthesis, and that's going to be our dynamic token. And then we have got the self.user data of CSR of token equals to dynamic token, where we store this extracted token in our user data, right? And the user data value is CSR of token, right? And this specific virtual user, which is known know its unique token, right? So that's what this self.user data of CSR of token equals dynamic token does. And then we have got the login data, which is equal to CSR of token. I'll just quickly show it to you. So in line number 42, we have got the login data, the username, the password, and the CSR of token. So this is where we are gonna replace the extracted value, right? As I told you in the very beginning. So we need to pass the value, the CSR of token value, right? Which we extracted in our previous response. So here, until this part, we are extracting the CSR. So we are using this command. We extracted the CSR of token and we are saving it in the CSR of token value. And then we are using that value to pass as part of the next request, right? The subsequent request. Okay. And that's what we're using it here. And then we do the post login check. Again, we add checks to the post request status code and content to confirm the login was truly successful. And the rest everything is fine. It's the normal request where we do the checking of the dashboard and everything else. And there you have it. Our Locust script is now will successfully correlate the dynamic CSR of token, which will allow our simulated users to log in correctly. So there won't be any failures. But let me quickly run it to show you how does it really work. ls cd, where am I handling? Yep, handle ls, and then locust minus f locust file.py. So yeah, it was my fault. I haven't activated the locust environment, and now I'm into my part again. So locust.py, and I've started the test to run, and here we've got the web interface where we got the test to run. But all I need to see is the values that are running here. So what I'll do is let me quickly stop it and I'll do a headless test. So I can read the responses here, right? And we can see the responses here. So here you can very well see, yeah, we are extracting the token. Yeah, so here you could see it, right? So we're extracting the token and the correlated values are there. And yeah, this is what I wanted to show you. So the extracted token, CSR of token is here, and then the submitter is login with the token, right? So this is how exactly the application works. So where we are able to do two actions. One is extraction and then the submission. So let me quickly reiterate. So I have a application, a small application where I log in. So my duty or my task is to extract the CSR of token, which I get it in the landing page, and then I'll have to pass it to the along with the login, right? So that's what I am going to do. And for that, what I do here is I need to extract the value the moment the landing page loads. And how do I do it is I use the RE library where I import the regular expression module. And then the next step is I am gonna use the regular extraction. So I'm gonna use this command, which is match equals re.search of, and then the CSR of token, and then the value where I'm gonna extract the values, right? So once I extract this value, I will paste the values in the next step, which is in the self.user data, where I use the dynamically extracted token and I paste this value, right? So this is how exactly it works. And all these details will be shared with you by the developer or with the BA, so you can very well understand how does it really work. So overall, what is the key takeaway is correlation is very essential for handling dynamic data in modern web applications, and Locust being a Python based, which gives us the full power of Python's RE module for flexible and robust correlation. And you can always use a non-greedy quantifier in your regular expression to avoid overmatching. And also you can store dynamic data in self.user data, so each virtual user maintains its own context, and you can add robust error handling too for your tasks, especially after initial GET request where you're expecting to extract the data. So that wraps up our deep dive into correlation with Locust. I hope this hands-on demo has given you the confidence to tackle dynamic data in your own load test, where you can build a resilient and accurate load test script, which is very crucial. And correlation is a very fundamental skill to get you there. If you find this video helpful, hit that like button, subscribe for more performance testing content, and let me know in the comment what other Locust topics you would like to see. Happy testing. See you all very soon. Until then, it's bye bye from your favorite YouTube Little Star YouTube channel. Take care and bye bye.